We are going to begin by working on some word problems. And most of the work that we're doing is going to come in the form of word problems. So we're going to do a couple things with this problem. We're going to figure out how to deal with word problems, and we're going to use the factor label method to find an answer for the word problem. So we're going to begin by looking at the word problem and reading through it. The biggest thing that I think people get concerned about with word problems is they see all these words and all these numbers, and it's a little overwhelming, and it's hard to understand what exactly they're saying and what exactly they're asking for when you have these things all mixed together. So what I'm going to tell you to do with every word problem we have is pull out the information from the word problem so you have all the numbers in one spot. Then you can more easily think through the process of solving the problem, and you don't have to worry about all those words. So let's go ahead and read through this problem, and as we read through the problem, we're going to pull out information. The person took 300 milligrams of trazodone each evening. So that's a piece of information. They had 300 milligrams of this drug per day. Okay. And they say that they took it for 1 year. It asks how many pounds, so I'm going to write down how many pounds, that's what we're looking for, would they consume, and then we're given this conversion factor. 454 grams are in 1 pound. Okay. So now we've pulled out all the information from this particular word problem. Now we can actually think about how to actually solve this problem. Now, generally, not all the time, but generally with most of these problems, we're going to start with a thing that's not the conversion factor. So the one number here that's not a conversion factor is 1 year. So that's where we're going to start. Before we get started, let's think about the logic of how we're going to proceed with this problem. Okay? We have years. We're going to start off with years, we said. And we need to get it to pounds. So let's think through how we're going to do that. Well, we can't use this one. It says grams and pounds, and we're dealing with time. This one is dealing with days. Well, that's time too. So there's a connection there. You want to see that connection. Can we convert years to days? Well, yes, we can. Hopefully we understand that 1 year equals 365 days. If by chance you come across a conversion factor that you're not given, that you don't know, it's not a metric conversion, maybe I'm assuming that it's common knowledge and you don't know it, or you've forgotten it in the stress of an exam or a quiz, ask. Always ask. And I'll tell you what the conversion factor is, or I'll tell you, you should know that, and I can't tell you. But that's the worst that's going to happen. So always ask if you can't remember, something like how many days are in a year. So if we use this conversion factor, we can convert from years to days. Then we can use this conversion factor, convert from days to milligrams. Well, milligrams is on the same order as grams, right? Milligrams and grams, they both have grams in them. So we can use a metric conversion for our milligrams to our grams. And then we can use this conversion factor to convert from our grams to our pounds. So this is our thought process. We're going to use this information up here to answer this problem. We said we're starting with years, so let's go ahead and get our grid up there. If years are in the top, where do years have to be to cancel out? Well, they have to be in the bottom. So we're going to put our years in the bottom. We said we're using this conversion factor first to convert from years to days. We've got 1 year. We want to go to days, so days is going to be in the top. And the number that's associated with it is 365. 365. We cancel those units out, years and years. We're going to end up with days. That's not what we're looking for yet, so we have to keep going. From days, we said we could get it to milligrams using this conversion factor. Now, days is on the top here, so where does it have to be in order to cancel out? Well, days have to be in the bottom. And from our conversion factor, we see that there's 1 day. Now, what's on the other side of the line, we put on the other side of the line. So we have 300 milligrams, 300 milligrams. That goes on top. Alright, so we did this conversion. We converted days to milligrams. Let's get those units canceled out. If we stop now, the answer would be in milligrams. That's not what we want. We want pounds, so we have to keep going. Now it says we've got to change from milligrams to grams so that we can use that conversion factor. Not a problem, because that's a metric conversion. We know that. And if we need to, we can write our King Henry doesn't bother drinking chocolate milk on the side over there. We want to go milligrams and grams. So basic unit is here. And we go 1, 2, 3. That tells us we've got 3 zeros. That's 1,000. Of the small guy. The small guy is on the bottom. That's the milligrams equals 1 of the big guy. Okay. So there's our conversion factor. Let's look at how we're going to put it into the problem. We've got milligrams on top, so where do they have to be to cancel out? They have to be on the bottom. So we're going to put the 1,000 milligrams on the bottom, and the other thing we're going to put on the top, 1 gram. And we get our units canceling out. If we stopped here, we would have units to grams. It's not what we were asked for, so we have to use that final conversion factor to get our grams into our pounds. Okay. So we're on this last step here. Now grams is in the top of the problem we're working. So where do grams have to be to cancel out? They have to be in the bottom. So we're going to put our 454 grams from our conversion factor. That goes in the bottom over here. The thing on the other side of the line, the 1 pound, that's going to go on the other side of the line in our conversion factor. No problem. 1 pound. Now we're going to cancel out grams and grams. The only unit in this whole thing that we didn't cancel out yet is pounds. So our answer is going to be in pounds. That's what we're looking for, so we know we're on the right track. Remember, that unit can be a double check to make sure that you're on the right track and you're doing the math right. So if the units work out, now we'll spend the time to plug things into the calculator. Okay. We have 1 times 365 times 300 times 1 times 1 divided by 1 divided by 1 divided by 1,000 divided by 454. And the number I get with my calculator is 0.241189, etc. So what's the one thing we need to do to finish this guy off before we move to another problem? Significant figures. Very good. So let's look at the significant figures. Here we've got an exact number, 1. There's 1 here. And 365 is an exact number too. Now we're going to treat it as an exact number. Here we've got 300 milligrams. That's how much drug was given. That's not an exact number. But there was no decimal point there. So this guy really only has 1 significant figure. Okay. Metric conversion, those are exact numbers. And the 1 pound is an exact number. But the 454 is not. So we've got 3 significant figures here. 1 and 3, the smallest of those is 1. So our answer needs 1 significant figure. Go ahead and, if you're concerned about your significant figures, write how many significant figures you expect in your answer over here, just like I'm doing. Because then even if you mess up in actually the final number, I'll know what you were intending to do, and I can give you partial credit for that. So make sure you write out as many things as possible. The more I see, the more I can give you credit for. Okay, so 1 significant figure here That's basically just that 2. So we go next door for the 2, we see this 4, we determine, hey, that's below 5, so we need to round down. So our answer is 0.2 pounds. That would be the correct answer with the correct number of significant figures. Now some people get concerned with, well, isn't this more exact than this one? And the answer is no, because all those digits out here have error associated with them. And if there's error associated with them, then they can't be relied upon. So 0.2 is actually more accurate than having more digits in the number. Okay? So do keep that in mind.